Hello everyone, this is Poornima Deepthi, working as an assistant professor in the Department of Electronics and Communication Engineering at MLR Institute of Technology. So today I'm going to explain the interfacing of stepper motor with 8086 microprocessor, as this video is a part of series microprocessors and microcontrollers. The overview of today's presentation is what is a stepper motor, why we are using stepper motor and where we can use stepper motor, what is the internal schematic of 4-winding stepper motor, how to protect the windings of a stepper motor, and how to interface a stepper motor with 8086 microprocessor, and what is the program to interface a stepper motor with the 8086 microprocessor. So coming to a stepper motor, what is a stepper motor? As you all know that a stepper motor is a device which is used to rotate the shaft at particular steps. So what is the main difference between the AC-DC motors and a stepper motor? So AC and DC motors are the motors which rotate continuously, but a stepper motor can be obtain the exact position where we need to stop the motor, or exact step. At particular step we can stop the motor. Actually these stepper motors have been using in the printers or washing machines like that. So by using, most of the times we will use stepper motor with the microprocessor itself. So and how does this stepper motor works? This is the physical view of the stepper motor. Here there are two things. One is rotor and another one is stator. As the stator is the stationary part, which will be like this. This is the stator. So stator is a stationary part. It doesn't move, and the rotor is the rotation part. So this is the rotor. When this rotor rotates, it will rotate with the exact step position. So that's why we are naming it as a stepper motor. And these stepper motor rotations will employ like the shaft in terms of steps. So rather than continuous rotations in case of AC and DC motors, this stepper motor will rotate depending upon the steps of the staff. So here the rotor, the shaft of the stepper motor, a sequence of pulses will be applied to this motor. Pulses is needed to apply to the windings of the stepper motor to get the proper sequence. So coming to that, how can we apply the pulses? The number of pulses required for one complete rotation of a stepper motor will depends upon the teeth, rotor teeth of the stepper motor. Suppose if we want to complete one complete rotation like 360 degrees, how many pulses are needed to, how many pulses are required to rotate the stepper motor? So it will totally depends upon the teeth of the internal teeth of the rotor. So as you all, so this is the windings and this is the teeth. This is the teeth of the stepper motor. So these many, how many teeth will be there in the stepper motor will be equals to the number of pulses we need to apply to get the complete one rotation of a stepper motor. So the stator teeth and the rotor teeth, if we want this stator teeth and the rotor teeth will lock at particular step, so that we can stop the stepper motor at particular step. So stator and rotor teeth will be getting locked. So with these pulses applied to the winding inputs, the rotor rotates by one teeth position. So what is the angle or the teeth angle of that position? So we can get the teeth angle depends upon the x. If we consider x as the angle, then the total, how much per one rotation, how much angle the stepper motor will rotate depends upon the 360 degrees divided by number of rotor teeth. Suppose let us take that the considered stepper motor is having 200 teeth. Then what is the angle it will move per one? So 360 by 200, which is nothing but approximately 1.8 degrees. So if we are taking 200 teeth stepper motor, or most of the cases 4-phased stepper motor will having the teeth of 200. So to get one angle, how much angle it will rotate for one step, you can get by using 360 degrees by number of rotor teeth. So coming to, this is the internal schematic of a stepper motor. Here this is the stationary part. It won't move. It will be like stationary part. And here this is the rotor. This is the rotating part. It will move according to the pulses applied to these windings. So these are the This is the 4-phase stepper motor schematic diagram. So here, if we consider this as the A phase, this is B, and this is C, this is D. So now, if the stepper motor want to rotate, now the excitation from, if the excitation started from A, if the stepper motor is rotating clockwise, the excitation will be moved to B, and then it will need to be moved to C, and then it will move to D, and then it will move to A. Like this, the excitation is needed to rotate the stepper motor. So here permanent magnetic poles will be there. So when we are applying pulses, the pulses to these windings, the motor rotates according to the magnetism. So coming to the winding arrangements, the winding A, winding B, winding C, and winding D. So most of the cases we can apply stepper motor directly, but protection circuit of a stepper motor is considered. Why? Because if we are getting high power, so most of stepper motor will works on 12 volts power supply. So if the high currents passes through the circuit, then the windings will get ruined. So to stop this getting ruined windings, we will be attaching one diode parallel to the windings. Parallel to winding. So if the high currents passes through this winding, the diode will get open circuit and the current will passes like this. If the supplied voltage is proper, then only the windings will be getting the voltage. So this is the protection circuit for one winding. So if we are taking 4-stage or 4-phase stepper motor, then for 4 windings we need to give protection circuit for 4 windings. So coming to the, so here one question is there, like design a stepper motor controller and write an ALP rotate shaft of a 4-phase stepper motor. Here they are saying that we need to take 4-stage stepper motor. Suppose this is the A stage, this is B, this is C, and this is D. If this is the 4 phases, phase A, phase B, phase C, phase D. And what they are asking, we need to rotate the stepper motor in clockwise 5 rotations and also in anti-clockwise 5 rotations. So before writing or before giving the circuit diagram, interfacing diagram of a stepper motor with the microprocessor, we need to give the excitation sequences. We need to identify how to rotate the stepper motor from which phase to which phase and how it will need to rotate. So this is the clockwise rotation, excitation table of a stepper motor from clockwise rotation. So basically in first step, the excitation will having at A position. So it is a rotating in clockwise rotation. So next B will be having the excitation. Next again, for another step, C will have the rotation. Another step, D will have the rotation. See, in first step, A is having the rotation. And in second step, B is having the rotation, excitation. In third step, C is having the excitation. In fourth step, D is having the excitation. Suppose in fifth step, there is only 4-phase stepper motor. So again, the first A phase will get the excitation. This is the excitation table for clockwise rotation of a stepper motor, because they have asked for 5 rotations. That's why we have taken for 5 steps. So this excitation, this is the excitation table for the anti-clockwise stepper motor. As I already told you, this is a 4-phase stepper motor, A, B, C, and D. Usually, if the excitation is happening at the D stage, so this is the anti-clockwise stepper motor. So anti-clockwise means the excitation need to move to the D stage. See, in first step, the excitation is at A, but in second step, the excitation need to move to D. So in next step, the excitation need to move to the C and excitation need to move to the B rotation. So in first step, if the excitation is at A phase, in second step, the excitation need to be at D phase. In third step, the excitation need to be in C. Likewise, the fourth step, excitation will be B, and fifth step, the excitation need to get back to the where it started. So this is the 5-phase excitation table of a stepper motor in anti-clockwise direction. Now see the how to write a program using the interfacing stepper motor to the 8086. So as I already told you that to interface a microprocessor to any input-output peripheral devices, it is necessary to give the combination with 8255 PPI, Programmable Peripheral Interface. So we can't directly interface any output input devices to the microprocessor by using we need to interface a microprocessor to the input output peripheral devices by only using 8255 programmable peripheral interface. So the inputs all will be connected to the 8255. From 8255 we need to connect the stepper motor. So now, to connect 8255 it is necessary to write CWR to use all the ports of 8255. So now to write a program, it is compulsory to write the CWR code word register of 8255 to interface any input output devices. Now tell me, here stepper motor, whether it is acting as an input device or output device. So here stepper motor is used to operate the printer, right? So it is an output device. So that's why here we will consider all ports as output ports, and here it is a 4-phase stepper motor. So 4 pins of any port can be used. So usually in this current program I have been using port A as output port, which I'll be using in the program. So now we need to write the CWR register. So CWR register, as this is an input output device, so what will be the CWR register? A CWR register of 8255 is 8-bit register. It is having D0 to D7 bits. Now the D7 bit will decide whether we are taking as a BSR, bit set reset mode, or input output mode. To know more about 8255 PPI, I have already given the video class regarding 8255. Please do watch that. Here, if we want to connect the stepper motor, as it is an output device, we need to treat it here 1. If it is 0, then it will be the BSR mode, bit set reset mode. So the next 2 will decide the mode of port A, and this one is whether we are taking port A as input or output port, and D3 will decide port C, upper, input output, and D2 will decide port B, mode, and D1 will decide port B, input or output mode, and last one port C, D0 will decide port C, input or output mode. We need to take the prescribed bits over this. So here they didn't mention any port, so I was taking the basic input output mode 00, and port A, I have already told you that I have been using port A as the output port. Port A is also 0. So now in this particular thing, I will assign I will take all the possible ports as output ports. So that's why what the upper byte 1000 and the lower byte 0000. So in this decimal you can write, or hexadecimal you can write, this is a 8 and this is 0. So 80H is the code word we need to load to the CWR register of 8255 to make port A as an output port. Not only port A, all the available ports, port A, port B, port C, here I'll be using as an output port. So now coming to the program, these are used to initialize the code segment and data segment. So start move AL, the lower AX register have been using to load the, because CWR register is 8-bit, so we will be using AL. So 80. You can't directly load the CWR register, you need to take the internal register. So that's why I've been moving 80 to AL, and now AL is loading to the CWR register. Now our stepper motor R8255 is able to set that port A have been using for the output port, port B is also using for output port, port C is also using for output port. Now coming to the next thing. So here, what are the phases? D, C, B, A. So to give inputs to the 4 phases, only 4 bits are required. But here we are having, for port A, we have been using 8 pins, port B, port C also using 8 pins. So I was taking port A. So 8 pins will be required. So that's why I am loading port A as 88. Loading port A as 88. Because in excitation table, I have already told you that in clockwise direction, A excitation need to move from A to B, B to C, C to D, and again D to A. This is the excitation we need to. So that's why here I've been using. So first I've been loading port A with 100088, right? Now I've been calling. So the excitation is at the phase D. Now I was producing some delay. So delay, it will jump to the call delay program. So where I have written call delay. So here I have been losing CX with some data. So until this count decreases to 0, it will be in wait state. So until it will get 0, if decrement to 0, then it will move to the loop. So here it will jump to the again loop. Now coming back to here. Next one is ROL AL comma 01. ROL means rotate left. So the AL register port A will be rotated to the left. Left means this A will move to this left. So it will move to here, rotate option. So what it will become? This bit will move to here, this bit will move to here, this bit here, and again. So like this, everything will be moved. So what excitation will come at 1. Now this 0 will be moved to B, 0, 0, 1, 0, 0, 0. This is the position what we are getting after rotating one bit. So the excitation now, after one step, the excitation is moved from D to A. So when here it started, it moved to A. Next, in second position, so now what is the value? 11. This 11 will be again moved to the AL register until count repeats to 0, until count reaches to 0. Here I have been using CX register as 1000. Why? So usually you know that CX register is used for count purpose. So here they have already mentioned that they need to move 5 rotations, 5 steps. To move 5 steps, I have been taking. So actually I told that 200 rotor teeth will be there. So approximately for one step, it will be taking 200 steps, 200 rotor positions. So to rotate 5 clock rotations, I need to have 5 into 20, which is nothing but 1000. So for 1000 complete rotor angles, then only we will get one complete step. So for 200, it will be one step. So 1000, it will be having 5 steps. Likewise, here we are using. So by using this rotate left option, we are using the clockwise. We are moving stepper motor 5 times clockwise. So to get the anti-clockwise direction, we've been using ROR, rotate right. So the stepper motor will rotate right. Until now, I have discussed what are the stepper, how we are using stepper motor, why we are using stepper motor. Apart from the DC and AC motors, where we can use a stepper motor, and what are the rotor and stator positions of a stepper motor. So this is all about the stepper motor. Thank you.